sum and difference formulas. So we're going to try to derive formulas for the sine and cosine of the sum of two angles and also for the difference of two angles. Here we're starting off with one angle, alpha, in its own triangle here, and I'm going to stack on top of it another angle, beta, in its own triangle. For simplicity, I'm going to let the hypotenuse of the beta triangle be equal to 1. And then let's focus on that triangle for just a second. So that triangle, because the hypotenuse is 1, the opposite side is just going to be the sine of beta because it's opposite from the angle beta. And the adjacent side to beta is just going to be the cosine of beta. And that's because the hypotenuse is 1. Now let's bring back in that alpha triangle. So this is the alpha right triangle here. And what I'm going to do from this very top angle on the beta triangle, I'm going to drop an altitude all the way down to the base of the alpha triangle. So when I drop that altitude now, I've created a right triangle that has the angle alpha plus beta. And actually the altitude I just dropped would be the opposite side of that angle alpha plus beta. And because the hypotenuse is 1, it would actually be the sine of alpha plus beta. So this altitude I dropped here is the sine of alpha plus beta. In order to find out the length of that altitude, in order to find out how long this is, I'm going to drop a horizontal perpendicular to it from this 90-degree angle right here. So I'm extending a perpendicular to that opposite side of alpha plus beta. And the reason I'm doing that is because I want to know something about these angles up here. Whenever you have two coplanar parallel lines cut by a transversal, you create equivalent angles called alternate interior angles. They're alternate because they're on alternate sides of the transversal, and they're interior because they're interior to the two parallel lines. What I've done here is because I've extended this perpendicular here, I've actually created two parallel lines cut by a transversal. The two parallel lines are the base of the alpha triangle and that perpendicular I just extended. Those are the two parallels, and they're cut by this transversal here of length cosine beta. That means that this angle alpha is an alternate interior angle for this angle here, so this angle is also alpha. And because this angle is alpha, and the entire angle here is 90 degrees, this angle up here has to be the complement of alpha, 90 minus alpha. But also, because this is a right triangle that has a hypotenuse of length sine beta, I know that the other two angles in a right triangle, other than the right angle itself, those two angles have to be complementary also, and the complement of 90 minus alpha is alpha. So this angle up here has a measurement of alpha. So I'm going to focus on that triangle and that angle alpha, because what I need is the top part of that length that I said was going to be the sine of alpha plus beta. So this distance right here is the top part of that length. And you'll notice that that length is adjacent to angle alpha in a triangle that has a hypotenuse of length sine beta, which means that that length over the sine of beta is the cosine of that angle alpha that it's adjacent to. I can solve this for x to find that distance, and that means that x is equal to the sine beta times the cosine of alpha. This is a part of the distance that's equal to the sine of alpha plus beta. I just need to know this other part of the distance, and that will tell me what the sine of alpha plus beta is when I add those two lengths. I notice that this distance right here, though, is one part of a rectangle, and opposite from it in the same rectangle is this distance right here. So if I can find this distance, it's the same as this distance. This distance is easier to find because this distance is opposite from this alpha angle in this alpha triangle. So I'm looking for this distance y right here, and I know opposite from it is this angle alpha. And the hypotenuse is equal to the cosine of beta from the very beginning of the video. So I know that the sine of alpha is equal to opposite y over hypotenuse cosine beta. And if I solve that for y, I get that y is equal to cosine beta times the sine of alpha. So now I know that this distance right here is equal to this, and I can bring back in the rest of the figure. So from here to here is the sine alpha cosine beta. From here to here is the sine beta cosine alpha. So if I want this entire distance from top to bottom, I just add those two parts. And because this is all in a triangle that has a hypotenuse of 1, and this is opposite from the angle alpha plus beta, that means that this is the sine of alpha plus beta. So that the sine of alpha plus beta is just sine alpha cosine beta, which is from here to here, or actually from here to here, plus sine beta cosine alpha, which is from here to here. So now I found a formula for the sine of the sum of two angles. Now let's try to find a formula for the cosine. Well, the cosine is this adjacent side right here to the angle alpha plus beta. So this little distance right here is what I'm looking for, that little distance. So what I'm going to do is I'm going to bring back in that alpha triangle, because this little distance is a part of the base of that alpha triangle. So here's the alpha triangle, and I'm going to be looking for the base of this alpha triangle. And then once I find the base of this alpha triangle, I'm going to find the distance from here to here and subtract it away. All right, so looking at this triangle, I see that the hypotenuse is the cosine of beta, and I'm looking for the adjacent side to angle alpha. So I know that the cosine of angle alpha is the adjacent side y over the cosine of beta, the hypotenuse. I solve this for y, and I get that y is equal to the cosine alpha times the cosine of beta. So now I'm looking for the distance from here to here so I can subtract it away from y. But I notice that that distance is just opposite to the rectangle that was here if I bring back in that top triangle. So I'll bring it back in, and I see that this rectangle's distance from here to here is the same as the rectangle distance from here to here. So I'm looking for this distance from here to here. And I can use this triangle I just brought in to find it, because that side is opposite from alpha. So this distance x, if I do the sine of alpha, is equal to x over the sine of beta, the hypotenuse. And if I solve for x, I get that x is equal to the sine of alpha times the sine of beta. So now I have exactly what I need. I know the distance from here to here, and I can subtract it away from this entire distance to get the cosine of alpha plus beta, which is this little distance right here. So the little distance I'm looking for, the cosine of alpha plus beta, is just going to be y minus x, where here is y and here is x. So I have that the cosine of alpha plus beta is y, which is the cosine of alpha times the cosine of beta, minus x, which is the sine of alpha times the sine of beta. And there I found formulas for the sine and cosine of the sum of two angles. So there I found formulas for the sine and cosine of the sum of two angles. I'm going to use this knowledge now to find formulas for the sine and cosine of the difference of two angles. And in order to do that, I'm going to use the fact that the cosine function is symmetric to the y-axis, which means if you plug in a negative x value, you get the same answer as when you plug in its opposite, the positive x value. So cosine doesn't care about the sine of the angle you plugged in. It's going to give you the same answer either way. On the other hand, the sine is very sensitive to the sine of the angle you plug in. So the sine of a negative angle is the opposite of the sine of the positive one. We're going to use this fact and the fact that alpha plus negative beta is actually alpha minus beta to come up with the two formulas we're looking for. So first of all, we'll do the sine of alpha plus negative beta, which is just really the sine of alpha minus beta. And we're going to use that sine of alpha plus beta formula. So we get this when we plug in negative beta for all the betas. And because the cosine doesn't care about sine, the sine of alpha times the cosine of beta is what this one is going to stay. But because the sine changes when you plug in a negative angle, this is going to be the negative sine of beta, cosine alpha. And we get this formula for the sine of the difference of two angles. The only difference is subtraction instead of addition. And then we're going to do the same thing for the cosine of alpha plus negative beta. So we plug in the negative betas where we need to, remembering that the sign, when you plug in a negative angle, is going to change the sign. So this is going to change from a negative to a positive. But the cosine doesn't care, so this first term isn't going to change. And we get this formula. Instead of a subtraction, it's an addition. And these together make up the sum and difference formulas. So these are for the sine and cosine of the sum of two angles or the difference of two angles. Let's see them in practical use. So in practical use, you could use it to find the sine of an angle like this, which is a non-standard angle, but the exact value. We can find the exact value. Because we can find the sine of 105 by adding and subtracting standard angles. For instance, the sine of 105 can be viewed as the sine of 60 degrees plus 45 degrees. And when we do that, we can use this top formula to break it up into the sine of 60 times the cosine of 45 plus the sine of 45 times the cosine of 60. And we know all those angles, or we know all those trig functions. We know the sine of 60 is root 3 over 2. We know the cosine of 45 is root 2 over 2. The sine of 45 is also root 2 over 2, and that the cosine of 60 degrees is 1/2. So when we simplify this, we just multiply those radicals, get the square root of 6, multiply here and get the square root of 2, and this is all over 4. 2 times 2 is 4, 2 times 2 is 4. So we can put it all over one common denominator. And here we have an expression for the sine of 105 degrees. All right, let's take a look at another one where we're using the cosine formulas to find the cosine of 15 degrees. Now I don't know that exactly, but I can find the exact value because I know that the cosine of 15 degrees is the cosine of 45 minus 30, which are two standard angles. So I know the sines and cosines of both of those. This is going to be equal to, using this difference formula for the cosine of the difference of two angles, the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. The cosine of 45 is root 2 over 2, while the cosine of 30 degrees is root 3 over 2. The sine of 45 degrees is root 2 over 2, and the sine of 30 degrees is 1/2. So when I do all the multiplication, I'll get this. And when I add them together, I get this. So this is how we can use those sum and difference formulas